Have you ever wondered what makes a door rotate on its hinges, or how a car's steering wheel turns smoothly? These everyday phenomena hinge on a fundamental concept in physics known as turning forces. In the world of physics, turning forces, or torques, are the forces that cause an object to rotate or turn about a fixed point. This fixed point is often referred to as a pivot. A pivot can be located inside or outside the object. For example, the pivot of a door is its hinge. In a car, the pivot of the steering wheel is the axle. The turning effect of a force is also known as the moment of the force. The moment of a force depends on two factors: the magnitude of the force and the perpendicular distance from the pivot to the line of action of the force. Here's an equation to help understand this better. The moment of a force equals the force times the perpendicular distance. In scientific terms, this is expressed as m equals F times d, where m stands for the moment of the force, F represents the force, and d denotes the perpendicular distance. But the moment of a force doesn't just depend on the force and the distance. It also depends on the direction of the force relative to the pivot. This direction can be either clockwise or anti-clockwise. Think of a system of forces, like a seesaw at a playground. The net moment of this system is the sum of the individual moments. If the net moment is zero, then the seesaw is in equilibrium, and there's no rotation. This happens when the moments of the forces exerted by the children on either end are equal and opposite. But what happens when the net moment is not zero? Well, the seesaw will tilt or rotate in the direction of the net moment. This is similar to how a wrench works. It's used to rotate a bolt by applying a force at a distance from the pivot. So, to recap, turning forces are the forces that cause an object to rotate or turn about a pivot. The moment of a force depends on the force, the perpendicular distance from the pivot, and the direction of the force. The net moment of a system of forces is the sum of the individual moments, and it determines whether the system is in equilibrium or rotation. Understanding turning forces and the moment of force is a fundamental aspect of physics that explains many day-to-day occurrences. Whether it's opening a door, driving a car, or playing on a seesaw, these principles are in action. For more intriguing topics like this one, make sure to subscribe to the channel. Stay curious, keep exploring, and never stop learning.